Okay, we're going to be looking at number 54 from the textbook. And in the book, the wording of this problem says to find the complex fourth roots of the square root of 3 minus I. If you were to get this problem in WebWork, it would be phrased, suppose z to the fourth power is equal to the square root of 3 minus I. Find all complex values for z. So that involves taking the fourth roots of the square root of 3 minus I. So it's the same problem, it's just worded a little bit different. So the first thing you have to do is to put square root of 3 minus I in polar form. Now this was done in a previous video. So in that video, we showed that it was equal to 2 times cis of 11 pi over 6, where cis is that shorthand for cosine 11 pi over 6 plus I times sine of 11 pi over 6. So, so that's in a previous video. And we're going to be getting our answer in radians. WebWork wants your answer in radians. The book, I think, gives it in degrees. But if you're going to look at it in WebWorks, they want the answer in radians. So we're going to do the answer in radians. Okay, so once you have it in your polar form, then we do have this formula. So if we're finding all fourth roots, there's going to be 4 distinct roots. And the 4 roots, the 4 complex roots are going to be Z0, Z1, Z2, and Z3. Okay. And the formula that we have to know how to get that is, well, we're taking a fourth root. So we're going to take the fourth root of our R out the front, which is 2. And then we're going to multiply it by the cis of, and then we want this angle divided by 4. But remember, dividing by 4 is the same thing as multiplying by 1/4. And then we're going to add 2k pi. And then again, we're having fourth roots, so we'll divide by 4. Now, if you're thinking, where are you getting this from? This is a formula that you have to have memorized. It's a yellow box in the textbook. Okay, so there's a general case for n. And so this is the case where n is equal to 4. So there's the box from our textbook. So we're trying to find a fourth root, so n is equal to 4 here. And so that's where we get this from. Okay, and so let's see if we can just clean it up. I'm going to have the fourth root of 2 out the front, then times cis of, well, 11 pi over 6 times a fourth is going to be 11 pi over 24. And plus 2k pi over 4, well, after cancellation, that's going to be k pi over 2. And since we're trying to find fourth roots, k is going to be 0, 1, 2, or 3. And so this is how I'm going to find these different roots. Okay. All right, so for my first root, k is going to be 0. And so if k is equal to 0, I'm just left with cis of 11 pi over 24. That's my first complex root. And for my second one, well, I let k be equal to 1 in this formula. So I'm going to have the fourth root of 2 times this. And if k is equal to 1, I'm going to have 11 pi over 24 plus pi over 2 if k is 1. Now I need to rewrite pi over 2 as 12 pi over 24 if I'm going to put these together. And so 11 pi over 24 plus 12 pi over 24 is going to be 23 pi over 24. And that's my second complex root. My third complex root, again, this is the formula I'm using, is going to be the fourth root of 2 times cis of, well, this time k is 2, so I'm going to have 11 pi over 24 plus, if k is 2, I'm going to have 2 pi over 2, and that's going to cancel and be pi. So I need to, if I'm going to put these together, I need to rewrite pi as 24 pi over 24. I'm going to put these together. So I'm going to have the fourth root of 2 times cis of 11 pi plus 24 pi is going to be 35 pi. Okay. And that's my third complex root. And then for my last one here, I'm going to have fourth root of 2 times cis 11 pi over 24. Oh, sorry, that's Z3, not Z4. Plus, and my k is equal to 3, so I come here and I'm going to have 3 pi over 2. Now if I'm going to add these together, this needs to have 24 in the denominator, so I'm going to need to multiply top and bottom of that one by 12. So that's going to give me the fourth root of 2 times cis of 11 pi over 24 plus 36 pi over 24. And so I'm going to have the fourth root of 2 times cis of 47 pi over 24. And that is my fourth root. So we have my first one, my second one, my third root, and our fourth root. And that completes this video.